Bismillahirrahmanirrahim. Assalamu alaikum. Okay, we are discussing volume and surface area of 3D figures. Already we have discussed volume and surface area of a pyramid. And while discussing, I compared the volume and surface area of a pyramid with that of a prism. And what I told you about was that the volume of the pyramid is 1/3 of that of a prism, right? And we also calculated, we unfolded the pyramid and we calculated the surface area of the pyramid. Now let's discuss cones, okay? Cone. Okay, so we have to calculate volume of a cone, and for this also I'm going to refer cylinder. When we calculated the volume of a cylinder, how we did that? I said, okay, the cylinder has a circular top, circular base. Cylinder has a height. So when we are calculating the volume, it is usually base area into the height. So what is the base here in case of a cylinder? It's a circle, and the area of a circle is pi r square. So what we did was pi r square into height. That was a cylinder. Now let's come to a cone. Okay, this is a cone, right? And I have cut out a paper, and from that paper I'm going to make a cone here. Okay, this is my cone. Okay, the cone has a circular base, right? But you see that it is the top is pointed. The apex of the cone is a point, right? Circular base with this pointed top, right? So as in the case of pyramid, the volume of the cone is 1/3 of that of a cylinder, right? In case of a cylinder, what we did was we said, okay, it has a base area, circular base. It has also a circular base. So what is going to be? Pi r square. And this cone also has a height. And where is that height? Okay, this cone has a circular base, okay, and when it is a circular base, it has a radius, okay, and this cone has a height as well, and this is from apex to the center, and this is height, okay. So let's say the radius is r and the height is h. Okay. In case of a cylinder, it was pi r square into height, right? But in case of a cone, I said the volume is 1/3 of a cylinder. Okay, so volume of a cone 1/3 pi r square into height. Okay, now if I say that the radius is, let's say the radius is 7 centimeters and the height is, let's say 18 centimeters. So 1/3 into 22/7 into 7 square into 18, right? So we can cancel out 7 with that square and 3 here. So it is 22 into 7 into 9, and we can calculate it, and after calculating we'll get our volume, right? You can apply the calculator here and we can get the volume, and it's going to be, whatever the result is, it's going to be in centimeter cube. Okay, now, if we have understood volume, how to calculate the volume of a cone? Pretty simple, right? Now, let's talk about surface area. Okay, now we are going to talk about surface area of a cone. And when we have to talk about the surface area of a cone, remember this cone, and it has a circular base as well, right? So I'm going to unfold this cone. So what we have here, this thing. And in other words, what is this? It's not a circle, it's a sector, right? Okay, so I have a sector, okay, and here it is, right? Now, coming back to the cone, this cone has, what we have already discussed is a circular base and a height. But this height is from this apex to the base, right? But this cone also has another height as well, which is this. The cone has slanting sides, and those slanting sides also has a height, like from here to here, from here to here, it's a slant height. So we have got here another kind of height, it is known as slant height, and usually this slant height is represented with L. Right? Now, just remember, this is this area from here to here. This is slant height. This is slant height. Okay? If I'm holding it like this, what is it? From here to here, it is a slant height. I'm going to unfold this. What is happening? So this is here, L. Right? Slant height. Okay? If this is slant height, back to cone. Now, this cone has a circular base. Okay. So that means that underneath this base is a circle. So we have a circle over here, as here. And this circle has a radius as here we have already said this. It has a radius. Okay. Now, what we need is we need to calculate a surface area. So it means that the cone has two things, base and this upper part. And this upper part is basically a sector, right? So we need to calculate the area of a sector and the area of a circle. To calculate the area of a sector, what we need is this, we need this arc length. From here to here, we need an arc length. And what is in this case an arc length? This whole circumference, right? This is the circumference, right? If this is the circumference, what is the arc length over here? Think of it. Okay, since this cone is covering this circle, so if this circle has the circumference of 2 pi r and this is covering it, so this arc length is also 2 pi r. Okay? And if this would have been a complete circle, then in that case, the circumference of this circle would have been, because this radius is L, that would have been 2 pi L. Okay, bit tricky, but this thing has a circular base, and this is 2 pi r, and this thing is a sector, right? And this sector has a radius of L, which is the slant height. But we are just assuming that if it was a complete circle, then this circumference would have been 2 pi r L. Okay, now let's calculate, come to the point, and let's calculate the area of this sector, this cone, right? Okay, to calculate the area of a sector, let's take the ratios. Area of a sector over area of a sector over area of a circle is equal to arc length over circumference. Sector over circle, arc length over circumference. So here we have a sector here, we have a complete circle. If we have a complete circle, we have a circumference. If we have a sector, we have an arc length. Okay. So we are calculating area of a sector. So area of a sector over area of a circle. What is it? If this would have been a circle, it would have been area of a circle pi L square. Arc length, we have this arc length over here, 2 pi r, and circumference of this 2 pi L. Okay, we can cancel out these 2 pi's, 2 pi, and then we have area of a sector is equal to r over L into pi L square. L goes with this, so we have here pi r L. So we have, okay, now the formula for the area of this curved part, right? The area, surface area of a cone has two parts, curved part and a base. Okay, so surface area of cone is equal to curved area of curved part plus base. So what are we going to have? We have just found out the formula, which is pi r L and plus base. Base is a circle, right? And the circle has a radius r. So what is the area of a base? Pi r square. Okay, and we can also write it as pi and r common, L plus r. So this is the area for the surface area of a cone, and we can apply the value. Pi is 22 by 7. We have an area like we have here. 7 is the radius, and if we have L, we can apply that and we can find surface area of a cone very easily. Hope you got the idea. I tried to explain how we have arrived at a formula and how we can apply it. This part is only for the curved part. This is the total surface area of the cone, which is the curved part plus base. Got it? So thank you very much.